this one, you're always changing the fancy one. So in the top ones, we changed the squareds yesterday. We changed this one we changed co-squared. This one we changed sine squared. This one we changed sine 2x. So you're changing the fancy things, not the singles. You're rarely changing like a cos or a sine, because if you're changing those, they're like 1 over secant or 1 over cosecant, and that's making it harder, not easier, right? This one I saved for today because it's cos 2x, and cos 2x actually has 3 options. Okay? So on your formula sheet, when you look at it, they're down here. Cos 2x has cos squared x minus sine squared x, 2 cos squared x minus 1, and 1 minus 2 sine squared x. Those are your 3 options. Now, the option that you're going to pick is the one that works the best with what you have going on here. So I always go look to my singles. My single is a cos x. So would it be helpful for me to pick cos squared x minus sine squared x? I'm just making it more crazy. I could do that and then end up replacing the sine squared with the 1 minus cos squared and just make it excessively long. But I could go that route. Would I pick the 1 minus 2 sine squared x? Once again, now I have sine squares mixed with cos squares. I'm going to have to go up here and replace with 1 minus cos squared. So the only option that would be the easiest to do would be the 2 cos squared x minus 1. Right? So I'm going to replace that. We still have to get it equal to 0. The 1's actually cancel, so I'm left with 2 cos squared x minus cos x. Now, often, if it's a trinomial factoring, people are good. They're like, okay, I just let m equal cos x and I move on. If it's not, they just sit there and stare for a while. Remember, if you're staring, most often it's a GCF that you're supposed to be doing, but you're staring at it not knowing what you should be doing. Okay? So I have 2 terms. What could I do? Yeah, take out a cos. GCF out of cos x. And I take a cos x out, I'm left with 2 cos x minus 1 equals 0. And now I have cos x equals 0. And 2 cos x minus 1 equals 0. So try and get the answer to this between 0 and 360. So cos x equals 0 where x is 0, which is here and here. If I look at my restricted domain, it includes 0 but not 360. So we have to keep that in mind. Here we have x equals 90 and 270 degrees. Remember that if your restricted domain is in degrees, your answer has to be in degrees. If your restricted domain is in radians, your answer has to be in radians, right? And then this one, I'm going to get 2 cos x equals 1. Cos x equals a half. So where's cos positive a half? Here and here. Is that 60 and 300? So I have x equals 60, 90 degrees, 270 degrees, and 300. Now I want to show you something. We should be able to walk away from this knowing we got it 100% right or cry. Those are your 2 options. I hope crying is not the option you go with. But we should know. Because whenever we have an equation, we can always go up to the original and type it into our calculator. So I always type this one side into y1 or this one into y2. So I'm going to show you the varying levels. So we're going to type this into y1 and the 0 into y2. Everyone should be doing that. You can always check your answers. This is graphically though, so if they ask algebraically and you go only this route, you're in trouble. So I put the left side into y1. Cos 2x plus 1 minus cos x, and then 0. Now if I have the older calculators, not the colored ones, I would go over here to the slashed line and hit enter once because it makes it thicker. Remember how we went over that? Then press, what mode do we want to be in? degrees because our restricted domain is in degrees, correct? So I'm going to go to my mode and I'm going to make sure I'm in degrees. And then I'm going to go zoom, trig, just to get something to draw. Okay? The catch is, what's my restricted domain? 0 to 360, we agree? So I'm going to go to my window and I'm going to make it be from 0 to 360. Now, any answer, any intersection on here are correct solutions that I should have in my answers. You see? So I went from 0 to 360. So now I just find the intersection. Second trace 5. I'm going to find the first one. Hopefully it's 60. Enter, enter, enter. It's 60. Yay. And second trace 5. Enter, enter, enter. 90. Second trace 5. Hopefully it's 270. You can bounce up and down off lines, so this one's faster, so I just bounce down onto it. My computer is not liking me pressing this button. Enter, enter, enter. 270. So I know I'm right. I walk away really happy human, right? Got all my solutions. So confident, and I move on. You agree? Okay. Let's go to example 4. So you're trying out these two. The catch here is, what do I want my solutions in? In degrees. And I want general solution. I didn't give you a restricted domain. So you're going to add 360n, NEI, right? 360 degrees n, NEI. You're doing the general solution. So try these two out. Okay, we'll go through the first one. So we have sine 2x. Sine 2x, honestly, whenever I see that, basically just kind of want to throw a party in my head. So excited. There's only one thing you can replace with it, and you always replace it. So it's like, sometimes you're like, should I replace this, or should I replace this, or should I replace it with this one? If it's cos 2x, there's 3 options. Like, there's way more work. But when it's sine 2x, I'm like, 2 sine x, cos x. Thank you very much. I appreciate you. And then I just move on. Okay? So I get 2 sine x, cos x. Now, the reason why I picked this one to do specifically, we're not doing 3 and 5 until after the test, because we'll just confuse you more than help you for this test, so I'm just not pushing the example 3 and 5, because we make you have common denominators. But these kind of do lead into what we could do for the test on Thursday. Plus, it has general solution, which I think is important. Okay. So, we always have to move everything to one side. So I'm going to subtract the root 2 cos x, and it equals 0. Okay. Now, I can't trinomial factor, so what's the other option I'm going to do? Take GCF out of cos. I don't want to divide the cos over. If I divide the cos over, I've gotten rid of half of my solutions, okay? The great thing about checking your solutions at the end is if you are someone who oopsies and takes out the cos x, let's say, if you type the original into your calculator, you're going to say, hey, wait a second, there's more answers. Why is there more answers than what I'm getting? Oh, I divided the cos off. That's the problem. So it's always good to check. So we take out a cos x, and we're left with 2 sine x minus root 2 equals 0. And I get cos x equals 0. And 2 sine x minus root 2 equals 0. This one I'm going to add the root 2 over and divide by 2. So I'm going to get sine x equals root 2 over 2. So where is cos x equal to 0? Here and here. When you state general solutions are always with principal angles. So they're either all the angles from 0 to 2 pi and then onwards, or all the angles from 0 to 360 and onwards, right? You use your principal angles. So there's 2 ways I could state the general solution for this one. I can go, is it x? Yeah. X equals, If it's a written response, you can do every single solution just with a 360N behind it, and you're right. You don't have to lump them together. So this is one option I could do. I could go 90 degrees plus 360 to get there back, and back, and back, and back, plus 360 degrees N, NEI. And if you're someone who can't memorize the format, but you're going to wing it, never works out well for you. You won't put the N in the right spot. You're not going to put NEI. I get this whacked out like version of this. You're not going to get the marks. So make sure you can write it. You take the original principal angle, you add 360 degrees N to it, and then N is an element of the integers because the integers for 0, 1, 2, -1, -2. Then we can do our other one, which is 270 degrees plus 360 degrees N, NEI. And that would cover every single one of these. So you can do it that way, or these ones are actually specifically across from each other, right? So if I add 180 to 90, I get 270. If I add 180 to 270, I get back here. Add 180, get back here. Add 180, get back here. Or reverse, 90 minus 180, I'll get -90 and get all the coterminals. We agree? So they can write this as one solution, one general solution. They can say x equals, and you use the smallest principal, 90 degrees. But instead of plus 360N, they can go plus 180 degrees N, NEI. Now, I only show you this version because if this is a multiple choice, they might go this route, right? Or a numeric response, they might go this route, forcing you to go this route by saying all the solutions are covered by 90 plus Bn, NEI. What is the value of B? And you would say 180, right? They can force you into that, but in a numeric or a multiple choice. If it's a written, you can totally answer both of them. Do you see the difference? Neither one is better than the other, to be blatantly honest, unless it's multiple choice or numeric response, and you have to answer in what form they force you to. Okay? And we have sine equals root 2 over 2. Sine is positive root 2 over 2 here and here. So this is 45, and this is 135. Now, this one has no or option. I don't have one where I can put them together. Because people will say, well, they're 90 apart. So I can just go 40 plus 90. But then I'm also going to get 225 and 315 as my answers. And are those answers? No. So when these are not directly across from each other, you actually can't put them together. So I can go x equals 45 degrees plus 360 degrees N. N is an element of the integers. And then x equals 135 degrees plus 360 degrees N. N is an element of the integers. Like I said, if you use the Z, you're not incorrect. It's in a math textbook. It's totally integers. That's totally fine. We'll use I here. Now, I want you to go to your calculator. Now, we could move this all over to the side, set it equal to 0. Y1 would be 1 and 0 would be another, correct? And you'll get the same amount of solutions. Or we can just go like this. This is Y1. This is Y2. So try it out from 0 to 360 again. So I'm going to go. In my Y1, I'm going to go sine 2x. In my Y2, I'm going to go root 2 cos x. If I'm doing general solution, I'm going to look between 0 and 360 or 0 and 2 pi. So how many times is it crossing? 4. Do you see? And I had 4 general solutions technically, right? So I can go second trace, 5. My first one, hopefully, is 45. 45 plus 360 and NEI. Like, I could literally just find those. Now, if you show no algebra, and they ask you to do it algebraically, and you just use your calculator, how many marks are you going to get? Zip. 0, zilch, the big O. It's the saddest thing ever. But we can check this. Now, I want to show you that I could actually rearrange this. So instead of sine 2x and then this, like this, and I got the solutions, I could have moved it all to one side. So I could go sine 2x, and then move the root 2 over. So it'd be minus square root 2 cos x. But now what would be the left-hand side of the equation? 0. I'm going to prove to you I can move them around all I want. I'm still going to get the same 4 solutions. Now it's intersecting here, 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 and here, which are still the same solutions. Right? I could have moved also the sine x to the other side. Made the left-hand side be 0 and the right-hand side be root 2 cos x minus sine 2x. 1, 2, 3, 4. Same answers. So I can move them all around all I want. y1, y2. Right? And sometimes, because they test you on actual calculator outcomes, sometimes they'll say, determine how you would do this. Now watch. I just want to show you something. So if we look here, the first one was this. This is what we did. We did sine 2x equals root 2 cos x. We did this. And we did y1, y2, and then I find the x of where they intersect, right? That's what they'll say. Like they'll say, determine how you could calculate this graphically. And A would be y1, set y1 equal to sine x, set y2 equal to root 2 cos x, and find the x value of the intersection point. Correct? So that would be correct if that was A. Another solution they could say is, okay, sine 2x minus root 2 cos x equals 0. We agree? So this would be y1. We can make this be y2 or not, even if we don't make that be y2. What are we actually finding this time? The zeros, the x-intercepts. The moment you set it equal to 0, you're finding the x-intercepts. So they'll say, set y1 equal to this, determine the x-intercepts, or the zeros, or the roots, right? They don't have to say y2 equals 0. I make y2 equals 0 because the intersections I find easier than left bound, right bounds, but that's what they could ask. Or they could move it over there. And this be your y1. And then find the zeros again because it's equal to 0. Okay. So anytime you're actually asked to solve, whether it was quadratics or linear or this, or it's an exponentials or logs or whatever, you can check every single one of them using your calculator. Because you have two sides of an equation, correct? The moment you have two sides of an equation and one variable, then y1, y2, and find the intersections. You can check every single answer. So whenever it says solve on the diploma, you should know whether you should be happy or cry. Those are your two options because you can always punch it into your calculator and check, right? Great thing is if you get it wrong, who cares? Go back, now you know you got it wrong, go back, try and get the right answer. How could you get to it, right? You have a place to lead to. Or you get it right and you're like, yes, I can move on. I don't have to worry that this is wrong. Okay? All right. This was the other one. Now I'm going to replace it again with the same thing, the 2 cos squared x minus 1, because I have a cos. And minus the cos x over, and I get 0. So this could be very much like tomorrow, right? I could have a cos, not tomorrow, sorry, Thursday. I could have a cos squared x, a cos, and a number, and I make you factor it, right? Not the above. I'm not going to make you do that. That's chapter 6. But I could make you do this one, right? So we get 2 cos squared x minus cos x minus 1 equals 0. And I can you can either work with the cos x's, some people are okay with that, or some people like replacing it with m. Whatever you do correctly, you do. So 2m squared minus m minus 1 equals 0. And then I get 2m squared multiplies to me negative 2 and adds to me negative 1. Negative 2m positive 1m. Take out a 2m, I'm left with m minus 1. Take out a plus 1, I'm left with m minus 1. So I get 2m plus 1, m minus 1. And then when I factor it down, I get m equals negative a half, and m equals 1. Now, if you're like, I really wonder if she's going to give us one of these. Like, why would she do this? This is something that she probably wouldn't. This is something that I probably would. Like, this screams Mrs. Lepp, give me one of these questions. And if so, I probably would leave the code on that side, and you're going to have to move it over, right? Or the sign on that side, you have to set it equal to 0. Like, this screams a question that I would love to put on a test. Honestly, I think you should predict teacher questions, because there's certain things that like make our heart sing. A question like this with a beautiful answer in a nice like sequential order, nothing better really. It's like a gift. I just like marking them, except for when they're not done at all right, and then they make it kind of die inside. Those are the options. I'm lower. So this one is cos x equals negative a half, and then cos x equals 1. 120, 240. I'm giving up on this board. And then this one is at? Right. So this one, I can go x equals 120 degrees plus 360 degrees n, NEI. And then 240. Wow, board's doing awesome things. This is not frameable. And then this would be 0. Do we have to write the 0? Like if I go 0 degrees plus 360 degrees n, then I'm not wrong, but adding a 0 does nothing, right? So they're literally just going to write 360 degrees n, NEI. Now,